All right, so we are talking about volume today. Here's a triangular prism, a rectangular prism. We already talked about cylinders. What other shapes did I say we're going to be dealing with? Cones, pyramids, and spheres. And then cubes are a prism as well. So volume is the amount of space enclosed by an object. And then on each object, there are different vocabulary words. So the first one I need you to know is a face. A face is a flat surface made up of, that's not what I wanted to show you, sorry, made up of a polygon. So this next word blank is a polygon. So do you see all these shaded things right here? Those are faces. A flat surface, actually any of these flat surfaces are faces. By the way, this test is in 2 weeks. No, it's 2 weeks. It's 2 weeks. But I have
When is 2 weeks? On which day?
2 weeks in May. In May 9th.
No!
Why? Is that your birthday?
Yes.
Oh, I'm sorry. All right. But on your test, I do want you to know that I am going to have these different shapes around the room. If you ever want to raise your hand and ask for one. Can you open the door for me, Lily? Raise your hand and ask for one. You are more than welcome to. So these are just shapes to help you if you need help processing or understanding any of these things. You can ask, hey, can you hand me the shape? Or you can just get up. I'll probably have them at the front of the room. Get up and just grab a shape if you need it. All right? So faces. Faces are anything that's flat. Do y'all see these flat surfaces? These are all faces. Next, you have lateral faces. Faces around the figure that connects the bases. So, right here I have a triangular prism. Do y'all see that this is a triangular prism right here? Do you see how I have 2 triangles? These 2 triangles are my bases, meaning I would lay it on there, and on the bottom is a triangle, and on the top is a triangle. So bases are the faces. They never touch. You see how this triangle will never touch this triangle? Okay? And then your lateral faces are the ones that connect. This flat surface, all the way around. These connect my 2 bases. All right? So an example of a lateral face in this room are the walls. What would be my bases then?
Your top and bottom.
The floor and the ceiling are your bases. The walls are your lateral faces. So I'm going to say this and it's going to be real confusing. Listen carefully. All of them are faces. Your bases are also faces. You have your top and bottom, and then you have your lateral, which means around. Everybody underline that word, around. Bases are faces that are parallel, meaning they are never going to touch, and congruent, meaning they are the same. What did I just say was an example of bases? The floor and ceiling. Did I spell ceiling right?
I don't know. I'm just gonna follow it.
I feel like that's wrong.
Yeah, definitely wrong.
Isn't it C-E-L-I-N?
No, not like that.
Yeah, it's C-E.
Oh!
Dang, spelled it wrong.
I'm smart.
It's I-L-I.
Oh, you smart.
It's I before E except after C.
Wait, Miss, how'd you get that wrong?
Because I'm a math teacher. Alright, so your bases, again, they are the exact same shape, congruent, and they are parallel. They never touch. Okay? Next, we have an edge. An edge is a segment where two faces, I'm going to say intersect, but both of those words are right. Where two places touch, where two faces meet. Do you agree on this pyramid? I have a face and a face, two flat surfaces.
Yeah.
The edge is right here where they meet. In this room, what is an example of an edge? The corner. Now this room's weird because it has like a little box at every corner. But yeah, did your parents ever tell you to go to the corner when you were younger? They were telling you to go to the edge of the room. So that is the corner of the room. Can you please make sure you write corner of the room? Because do you agree the corner of a room is different than a corner of a box? What's the corner of a box? Don't y'all agree this is the corner of a box, just the point? That's not called an edge. Does anybody know what it's called, that point right there? A vertice or a vertex. That's the bottom one. A point where three faces intersect. So I'm going to say corner of a box. Or like the top of a pyramid. Do y'all agree the very top of a pyramid? That's a vertex. And I do want you to know a lot of times I'm not going to say vertex. I'm going to say vertices. That is the plural of vertex. That means more than one. So vertices is the same thing as vertex. And last thing is lateral edge. It's a segment where two lateral faces intersect. That's also the corner of a room. Alright. Oh, I should have brought my daughter's Play-Doh today. Darn it. Okay. If you can please open up your notes. We are now going to go through and answer these different questions. Did y'all write all this down? Are we okay, everybody?
Yeah.
All right, open up. You good, Dario? Okay. If we open up, what type of prism is this? Yep, you're right. This is a triangular prism. And what I would like you to do is I would like you to kind of shade the triangles. Those are my what?
Your bases?
My bases. So how many bases does this have? 2 bases. How many lateral faces does this have? Around the bases, how many are there? 3. Why are there 3 of them? What shape is this? Because it's a triangle. How many total faces are there? How many total flat surfaces are there? You are always going to add your lateral faces plus your bases, and that will always be your total faces. Yes.
How do we know for sure that those are the faces and not the bottom?
Because the bottom is a what shape? It's a rectangle, which it can be a rectangle. But remember, it has to be congruent and parallel to the others. This bottom touches these around, so it's not. Okay? Good question. Vertices. Remember, your vertices are your points. How many points are there on this?
6? Yeah, I think.
There are 6 points. Your lateral edges are the lines around. How many lines around are there? 3.
Wait.
The lines around, don't go to the bases, just around the lateral faces. How many total lines are there here? So 1, 2, 3 going around. 4, 5, 6, 7, 8, 9. There are 9 total. Do I need to do that again for y'all?
No.
1, 2, 3, 4, 5, 6, 7, 8, 9.
I get it.
Okay? Now, can I move on from this?
Yeah.
My next shape, what is this? This is a rectangular prism. And I'm going to be honest about rectangular prisms. They can get confusing because, how do you know which one's the base?
Because
It could be the bottom ones, but because it's a rectangle, don't you agree the top and the bottom could? I'm actually going to make it these two right here, but it should not matter which one you make the base. It'll still work out. Okay? So how many bases are there? 2. By the way, if it is a prism, it'll always have 2 bases. So because it's a prism, it has 2 bases. How many lateral faces are there? Around how many faces are there? 4. Why?
because it is.
Why?
Because there's 4 rectangles.
Not 4 rectangles, 4
Sides?
sides in a rectangle. So that, and then you're right, it creates 4 rectangles. But it's a rectangle, there are 4 sides, so there are 4 lateral faces. Over here, this is a triangle, so how many lateral faces were there? 3. So how many total faces are there? 6. How many vertices? How many points?
Let me see. 1, 2, 3, 4, 7, 8.
Yeah.
Oh yeah.
Just add the vertices of your 2 bases. Shh, ladies. Stop. Lateral edges. How many lines connecting around? 4. It happens every day. Quit being surprised at this point. And how many total edges? So we got the 4 around. 5, 6, 7, 8, 9, 10, 11, 12. And again, you're just going to be counting. I want you to do this next shape. What is the name of this next shape?
Is it not a triangle?
It is not a triangle. It is a pyramid. On the bottom, I'm going to tell you, it is a square pyramid. Jordan, can you? DJ, write this down, DJ. Where's your paper, DJ? Let's go, DJ. All right. I want you to answer all these questions. Go.
I hope I can, but if I don't, too late. Wait, how does this work?
I'm telling you it's a square. I'm telling you on the bottom, all the sides are the same.
It's a pyramid, Maya. It's a pyramid. And there's a square at the bottom. How many sides do you think?
I think that's practical side.
How many bases does this one have? Only 1. Why does it only have 1 base this time? Because it's a pyramid.
I said pyramid.
It only has 1 because pyramids only have 1 base. So it's because it's a pyramid that it only has 1 base. How many lateral faces does it have around? 4. Why?
Because there's 4.
Because there's 4 sides in a square.
4 times 3
There's
is
4
4
sides. I
triangles.
was gonna say 4 triangles again.
And 4 plus 1 is how many total faces? And again, on your test, if you're like, man, I can't visualize this. Like me personally, I have a really hard time seeing and drawing 3D things. Like my brain, that's spatial reasoning, has a hard time. If you want to physically come grab my square pyramid so you can count how many flat surfaces there are, again, I have no problem with that. Okay? You want to come grab it?
Yes.
All right. And then how many lateral edges around how many lines are there?
Is it 4?
It is 4.
So 4 times 3 equals 12.
By the way, FYI, look at on all of these, your lateral edges and your lateral faces. What do you notice about all of them? They're the same. And then how many total edges are there? Okay, so be careful. That was with a prism. It is 8. If it was a prism, Brian, you would be right. But because it's a pyramid, there's only one base. 1, 2, 3, 4, 5, 6, 7, 8. Okay?
Pyramids is times 2. Got it.
Yes. All right. What is not a prism, but kind of resembles a prism? A cylinder. So a cylinder is like a prism in a sense that how many bases does a cylinder have? 2. But the reason it's not a prism is because it doesn't have any vertices. It has 0 vertices. There are no points on a cylinder. Why? Because it has circles. How many edges are on a cylinder? How many straight lines?
3.
Straight lines.
0.
0. And although, hold on, I agree with you. Like right here, you're probably like, but Miss Alvarez, there's a straight line. Again, if you need help, come grab the shape. Come grab the shape. Are there any straight lines on this shape? No.
Thank you.
Write that down.
Cylinder acquired.
Okay. Are we all good with edges, vertices, cylinders? No, that's not what I meant. Edges, vertices, faces, bases. All right. We're talkative today on this Friday. All right. I need you to please look up. I have another mini lesson in here. Shh. Now we're going to talk about cross sections. A cross section, write this down at the top of your paper, is an image when a solid and a plane intersect. A solid and a plane, not like an airplane, but like a paper plane, intersect. So, here's an example of that. If I were to, y'all please look up, if I were to cut this pentagon, do y'all see how it's cut right there? If I were to cut this, what shape would you then see? So I want to show you this video. I wish I would have made it so that the people watching the video can see. But I want to show you this video of cross sections. Please watch.
Slicing solid, 3-dimensional figures results in different 2-dimensional shapes, depending on how you slice them. If you cut through a cylinder with a geometric plane parallel to the cylinder's base, the 2-dimensional cross-section is a circle. Any way you slice it, you can get 2-dimensional shapes from 3-dimensional figures. When you slice a cylinder from top to bottom that is perpendicular to its base, then look at the cross-section straight on. You get a rectangle. What happens when you slice a square pyramid? If you slice across the pyramid with your plane parallel to the pyramid's base, the cross-section is a square. If you slice with your plane perpendicular to the pyramid's base, the cross-section is a triangle. Remember, you're slicing a solid, 3-dimensional figure with a geometric plane. You can slice in any direction. Just keep in mind that shapes can look different when you look at them from different angles. So orient the cross-section.
So we're not going to be slicing diagonally at all. We are only going to be slicing vertically up and down or horizontally left and right. So I want you to look at your paper right here and kind of see if you can envision.
I sliced it diagonally.
Right, but we're not going to be doing that. What would happen here? So horizontal is which direction? If you don't remember, horizontal is left and right. I always like to do an H like that to kind of remind us it's left and right. So if I were to cut this cone left and right like that, what shape would I end up seeing?
Square?
No.
Circle.
A circle.
I thought they said
This is a cone. You have to look at, yeah. So you have to look at kind of what's on the bottom, what's going on.
So, is the base gonna be the same?
Yep, a lot of times it's going to be the same as whatever the base is. However,
It's not always, Brian.
what if were to cut this cone vertically, up and down? A triangle is what is going to happen. The other way I like to think of this is, do y'all remember stamps?
No.
I don't know when the last time you used a stamp was. But what if you were to cut this cone and stamp a paper with it? What shape would you see? That is what a cross section is. Slice this cone in half and stamp it on a piece of paper. That's what you see. I actually have this cone right here. In Pre-Cal, we do more cross sections, a lot more than this.
I was just talking about that.
Were you just talking about this cone? So this cone right here, if I were to slice it, what do you see?
A circle.
You see a circle. And unfortunately, it does not slice straight down the middle because I need it. But these are the different shapes that you can see. This is called a hyperbola. These are different shapes that you can see with cones. But if I were to cut it straight down the middle like this and stamp, what would I be stamping on here? What do y'all see right here? A triangle. So that's why it's a triangle. Alright. Yeah, I have a bunch of cones up there because of Pre-Cal. We do a whole thing on cones. Alright, what about this prism? What if I cut this horizontally, left and right? What if I were to cut this right here? What would I get?
What's that thing called?
A rectangle. Now, if you were to slant this, I think this is what you were talking about, Darielle. If you were to slant that a little bit, it would be more, well, no, I think it would still be a rectangle. Or would it be a trapezoid? No, I think it'd still be a rectangle. What if I were to cut this vertically up and down? A triangle. If I were to cut this up and down, it would give me a triangle. What about a cylinder? What if I were to cut this left and right? Slice it. He did this one for us. What if I were to slice this? A circle. And what if I were to slice this up and down? A rectangle. I tend to notice that my artists, y'all do very well at this. I am artistically challenged. So it's very hard for me to see these things. So if you're having trouble, if you want one of these things to visualize it, just let me know. What about this 1, 2, 3, 4, 5, this pentagonal prism? If I were to cut this, it says what? Horizontally, what would I see?
Is it a
Pentagon?
A pentagon. So this one says draw. So you don't have to write pentagon. I want you to draw what you see. I'm just gonna, again, I'm artistically challenged too, so that's as good as you're getting from me. What about toilet paper? What if I were to slice the toilet paper? It would be just one circle?
It's just a circle. Oh, it's a hole in a circle.
There would be a hole. Don't you agree if you were to slice the toilet paper and stamp it down? It would kind of look like a donut. Do y'all agree with that?
Yeah.
Because there's a... Oh, I got a bagel right here. You right. Can be a bagel. All right. So that's called cross section, slicing and figuring out what shapes. Last thing I want to talk about is rotating. If I were to spin this triangle around and around and around the pole over and over and over again, fast, what shape would I be creating? Let's see if I have a video to show you this. I don't. Okay, so let's show you. I'm going around. Let me get my Post-it note.
Circle.
If I get a Post-it, I'm going to do this as a triangle. Let me cut it with my scissors. Y'all look up here on my board. I'm going to try to do this. Do y'all agree I have it? Ah. Do y'all agree I have a triangle? It looks kind of like a flag. If I were to spin this around and around and around and around and around, what shape am I creating? It's going around. A circle's creating. So look, let's do that. Do y'all agree this is creating a circle because it's going around? And what shape does that create? What shape is on my paper now?
Is that a pyramid?
That is not a pyramid.
Cone.
A cone. Because it's going around, whatever shape it is should be circular. One of my circular shapes. What about a semicircle? What if I take this and I go around and around and around and around?
Hold on.
That would be
That would be a circle. A cylinder.
Three-dimensionally though, what would it be? It would be a cylinder. No, it would not be a cylinder. I said cylinder, but that's not a cylinder. What is that? A sphere. It would create a ball. A sphere. All right, that one, I'll have a video for you on Monday to show you that one better because I know some of us are like, I don't see it. All right, we are going to glue this. I think we only have like 3 more papers to glue for the whole year, y'all.
I haven't been gluing anything.
Oh, well, that's a you problem.
Hopefully your glue lasts.
We are gluing this on page, I don't think it is, 68. Let's glue this onto page 68. We will call this 3D figures. $3D figures. What do I got? I got a measly 6 of them.
You got this. They'll last.
I never
You can share that page.
Why? I grew up.
I forget.
Alright, 3D figures. And what you are going to do now for the rest of class, you're going to go into Schoology and do the Schoology assignment for today, please. Go into Schoology and do the Schoology assignment for today.